wasting time. So today we will discuss about just a minute. I just share my screen first. So my screen is visible to you.
Yes,
Okay. So today we will discuss about interferential statistic like the hypothesis testing, t-test, ANOVA, and correlation analysis. You know about the interferential statistic at the critical component for the data analysis, allowing researcher to make interference and the draw conclusion about the population based on the sample data. This module deliver into the core technique about hypothesis testing, t-tests, I mean both way, t-test analysis of the various variance, that's called the ANOVA, and correlation. Those are the powerful tool enabling the researcher to determine the significance of their findings, identify the relationship between the variables, and ultimately advise our understanding of the world around us. So this is the basic introduction, and now come to the hypothesis testing. So we know that there is a hypothesis called the null hypothesis and alternative hypothesis. So at the heart of the hypothesis testing lies the formulation of the null and alternative hypothesis. The null hypothesis represent the status, the assumption of no relationship or no effect. An alternative hypothesis produce the result that deliver from the null hypothesis, mean there is a significant relationship and difference between two means and the variables. So this is the alternative hypothesis. And the significant label, how you understand what is the p-value and what is the level of significance. Suppose we say that the significant, statistically significant, suppose when we write the interpretation, we generally write like this, statistically significant. But how you determine mine that the what is the label of the significance, and the what is the p-value, and how you determine, commonly denoted by a alpha, and it's p determining probability. P value mean the probability value. In the other hand, probability observation, observing the taste of the statistic, at least the extreme of the observed your variables, assume the null hypothesis is true or false. So suppose your confidence interval, you know about that 95% confidence interval, so your significant value less than 0.05, when the percentage is 5% within this. So if it is your confidence interval is 99%, so your p value will be less than 0.01, then it will be statistically significant. Got it? So here one thing you need to remember, your confidence interval. So from your data you need to understand that. And statistical test and the decision making, in that case we calculate the z score, t test, chi-square test. So evaluate the evidence against the null hypothesis. Well, the decision to reject or fail to reject the null hypothesis, that's mean, and based on the comparing the p value to the p determined significant level. So here you need to understand the significant level very well, otherwise your interpretation might be wrong. Got it? Then in significant test or hypothesis test, we use that one sample t-test and two sample t-test. First of all, you need to understand that what is one sample t-test. One sample t-test is used to determine whether the mean of the single population differs significantly from the hypothesized value. Okay, the test commonly employed when the researcher specify the value in mind and want to compare with uh, that sample mean. So that is when you will work with the one single sample or single population. So That time you need to use one sample t-test. And when you will use two sample t-test, sample t-test you use to compare mean to determine population. So there is a significant relationship between the two group of variables or treatment. Okay, so one is the controlled and another one is treatment. So you can also understand, is there any significant differences between the two groups. So suppose there is a male and female, so education level, so you can go into the two sample t-tests. So education level of the male population and female population, is there any significant differences or not. So this is two sample, and for example of one sample t-test, I give you reference. So in education, is there any differences to change the enrollment in the school after class 10 or class 12? So you can put the value in your mind, that is the 12. After 12, is there any significant difference within the group? So one group is pass out from you know 11 class 10, then they are enrolled in the class 12, for the class 12. Yes or no? So is there any significant difference or not? So that is the one sample. You took only one sample, that is one population who passed the class 10 exam this year. So whether they are enrolled in the class 11 for the higher education, for further education, so that is the single sample t-test. Got it? Then paired and unpaired t-test. In the paired t-test, when the data consists of matching pair or repeated measurement in the same subject, so test is applicable in the study where the participants are measured before and after intervention. Okay. So in physical education, there is a roomie and someone is there. So you know that suppose you were providing some training. Before training, you just take some sample from the player, and after, mean the post intervention, so you will take the same sample, suppose the blood sample. So how it's changed after training and before training. So those kind of the relationship you can find from the paired t-test. And the unpaired t-test, that is the independent t-test, like the student t-test, and the data consists of the two group or sample, and commonly used in the experiment for the participant randomly assigned of the different treatment group. Okay, suppose when we are collecting data through random stratified random sampling method, or random sampling method, that time we need to go into the unpaired t-test. Got it? And then assumption and limitation of the t-test. Well, so in t-test, first of all, normality. We discussed in detail about normality assumption. Normality assumption help you to measure the data is normally distributed or not. If the significant largely your population size more than 30 to 40, so your central limit theorem, so there is a theorem that is called the central limit theorem to hold. So you can justify that whether your sample size is sufficient or not. So that is one method. Then the violation of the normality can lead inaccurate result. Well, so in last class we discussed about when we will calculate mean, when median, when standard deviation, when mean deviation. So all are related with the normality assumption. If you not check the normality, so you might go into wrong direction. Okay, then homogeneity of the variance. Homogeneity of the variance, you from the normality assumption you can find the normality of homogeneity of the variance. So population being comparable or equal, and the violation of this assumption also lead the inaccurate result, particularly case of the unequal sample size. So suppose your sample size is not equal. Suppose you are taking the sample from the all the districts, so that should be equal from the every district. Otherwise might change the homogeneity of the variance. And the independence in the t-test, assume the observation are the independent one or another. Okay, so violation of the assumption, such as case of the repeated measure or clustered data, can lead to inaccurate results. So those things you need to keep you in your mind, like the normality, homogeneity of the variance, and independence. Those are the crucial factor when you go to check your t-test. Then one way analysis of variance, that's called the ANOVA. Okay, so purpose you need to understand, because in software when I demonstrate all those things, so you can easily calculate, you can get the value, but thing is that you need to understand that when you will go for one way ANOVA, when you go into two-way ANOVA, so that is also crucial thing. So many of you, I mean almost all of you, not from the statistical background. So those knowledge is very important, when you go into analysis. But otherwise, your result can be misinterpreted. So one way analysis is used to compare mean of three and more independent group or condition. So in the different conditions, suppose you have the three independent groups, suppose you are take the student of physical education, geography and political science, and you just take one performance, mean that that is a condition. Okay, so then you can go for the ANOVA analysis, one way ANOVA. It will give you the difference between the student of political science, physical education and geography. Is there significant difference in their performance in terms of the score, in terms of the many other thing also. Suppose you can go for the any kind of test. So assumption, similarly to the t-test and the one way ANOVA, also you need to check the normality. So it is clear to you that normality assumption is the first thing of a statistical, any statistical analysis. Then you will need to understand the homogeneity of the variance and independency of observation. So any case, and then interpret how you will interpret the ANOVA result. So sometime we write na, the result is significantly, significant, there is a significant differences between the two variable, or statistically significant, there is a, you know when we write suppose some test, so you need to do some post hoc test, such as Takis test, and that is the Bonfanni's correlation also there. So there is a some specific group of determinants, so why it is changed, and the value statistically significant from the t-test, you can say that the p-value is less than 0.05%. Also the there is a significant relationship between two tests. But in case of ANOVA, you need to go, there is a post hoc test. Post hoc test will specify the which group is differ. Okay, so it's one step ahead of the t-test. Then two-way analysis of the variance in the two factor, mean it's allow researcher to investigate effect of the two independent variables simultaneously on dependent variables, and it is useful when the study the interaction between the multiple factor. Suppose you try to understand the, suppose in my case I use two-way ANOVA in my thesis, when I try to understand, so passenger mobility of the railway station. So what are the factor which control the uh, number of passenger or passenger mobility for the station. So there is a in number of factor, like infrastructure, like frequency of the paratransport systems, and also the frequency of the train, and also there is some independent variables and some are dependent variables. So when that time you can go for the two factor ANOVA. And the interaction, in addition, the main effect of the each other, the two-way ANOVA can also detect the interaction effect and occur the one-way dependency. So here you need to keep in your mind, for one-way analysis you need not to know that whether it is an independent variable or dependent variable. But in two-way ANOVA you need to understand that what is independent variables and what is dependent variable. And the assumptions in two-way ANOVA measures same for the t-test, for one-way ANOVA, two-way ANOVA. Everywhere you need to understand your data. I mean, whether it is normally distributed, there is homogeneity in the variance and independence in observation. So those things you keep in your mind, then only you can go into better interpretation or better explanation in your data set. Otherwise, your result or your interpretation the mislead the the entire thing, entire process. Then repeated measure of ANOVA within the subject design. So you can repeated measure ANOVA. It's used when some subject or participant are measured under different condition. Okay, suppose you ask some question in morning and you ask the same question in evening. So is there any significant difference in this, with the same person, same subject? So even suppose you take one test, running, sitting, shooting, anything in the physical education student, in the morning session and evening session. So is there any difference between the with the passage of time in this with the same subject, same participant? So that time we need to check repeated measure of ANOVA and assumption same. And here one thing you need to add, that is the scarcity, that is the equality of variance across the conditions. So all conditions should be same, the player or your participant or your respondent, they should be same. Then the compound symmetry, compare symmetry is a equal covariance between the pair condition and also those are the, and the system you need to understand the counterbalancing or randomizing to control the your sample in the order effect. So it is the mean the randomization. What is the randomization? You need to understand that thing. When you collect the data, that should be a process. So that process, because in the random table you need to follow, random does not mean you go and take the data. So in the statistic, when you collect the data, you should be very much serious about that. So how you collect the data, what will be the procedure? Not like that you just make the questionnaire and go to the field, collect the data. No, it's might mislead the your entire process, because who are doing PhD right now or planning to enroll very soon, so they keep in your mind that you should be very much careful about your sampling design. So first you go to the pilot survey about the 40 sample, then you come out with the t-test, in the student t-test, so that you can understand that there is a significant relationship or not, mean whether your hypothesis is null or alternative. Then you can go for the big data set, and there is a also some technique you need to understand your total population, how much percentage of population you will take consider for your study, as well as you know you need to understand the method of data collection, how you will collect the data, what will be the procedure. So in the research methodology you might go through all those things in the research methodology classes, so you understand all those things. I will just stick on my subject in the SPSS. And the post hoc test and multiple comparison, the stuck is HSD mean the honestly significant difference. Okay, so it is a post hoc test for the pairwise comparison after the ANOVA. Based on that you can say say that there is any significant and all. The Bonfanoni correlation is a more conservative approach, means conservative in more traditional approach to adjust the significant level for multiple comparison. It divided the desired overall, significant level. I mean, suppose your desired significant level is 0.05 because your confidence interval is 95%. Okay, by number comparison, creating more, stringent criteria for significant test. And the games Howell test, game Howell test is a post hoc test that is robust your violations of assumption equally variance or particularly used for when the sample size are unequal or heterogeneously distributed. Suppose you are working in a Tripura state, so you are collect data from the different state district. Suppose there is a 8 districts, so population of the west district is much higher than the north or dhalai, so naturally you will take the data much higher. Mean your sample will be high in west tripura rather than the dhalai north or south or gamoti or anywhere else. So then that's mean that your sample size is unequally distributed or heterogeneously generality of the variance, so that you can go for the games oval test and you can understand whether your differences, if there is any differences that is significant, statistically significant or not. But it and the try correlation analysis, there is a two method facility, that the Pearson correlation. Correlation is for your the Pearson correlation R value. So Pearson correlation determining the linear relationship between two continuous variables. So always remember that your data should be the continuous variables. Okay, so the range from -1 to +1, the closer to -1 or +1, which is indicating that strong correlation. So is there any significant correlation or not? Suppose your question is that your research question is that there is a significant relationship between education and income. If your education is high, so your income will be high. So it is your hypothesis. So when you collect the data and go into analysis, you can think that it might not be, or the value is 0.75. That's mean positive correlation. But if your value will be that more than 8 or more than 7.5, you can write that strongly positive correlation, slightly positive correlation. Or if the value is nearby the 0, so that time you need to understand there is a no significant correlation between the two variables. Got it? And then you need to go into the Spearman rank correlation. So suppose there is a rank between one group, it is useful for the non-parametric measure or monotonic relation between between the two variables. Suppose there is a two subject, so one is maybe your special paper, another your is compulsory paper in the research methodology. So there is many option is there. So your rank based on your special paper and your compulsory paper. So if you go into correlation among the students, so you can go into the Spearman rank correlation. Even in case of, if you give the example of the district, so the based on the population you just rank out the uh, your districts. Suppose in terms of population you give the rank of the West Tripura 1, the second is North Tripura, third might be in the Udaipur Gamoti Tripura. Like this way you can just rank this, and based on that, the suppose Devojyoti is working on the crime against women, so he can also give the rank based on the crime against women, because when we don't have the exact figure of the crime against women's data set, so but you have the one data set, so you can understand that there is in the Dhalai district might be in the less number of crime against women, but West Tripura, so there is a crime and rank is high, so you can put the rank based on that variable, and then you are correlate with that in the district. So there is a population high, so there is a violation is also high. So like this way you can go for the Spearman rank correlation analysis and the interpretation of the correlation. In that case, when correlation does not imply any causation mean it is the important to understand the limitation of the correlation analysis. Consider the one factor such as the confounding variables, mean there might be many variables. Suppose crime against women, that does not mean the population is high, so that's mean there will be the many crime. No, not like that. There is a many factor like that, many socio-economic factor, many other factor also. So you cannot come into the conclusion by saying so there is a positive relation. So when you are interpreting the result, so the question come from the correlation. So there is a relationship, but uh, there is one method in econometrics, so they are called the externalities analysis. From the externality analysis, so you can also find other which is non-forcing factor you can also consider over there. Well, and then partial and multiple correlation. Partial correlation measure is strong in the linear correlation between the controlling factor and one or more additional variables. But in multiple correlation, the concept of correlation situation where there are more than two variables are involved, and the measure strong linear relationship between the dependent variables and a combination of the interdependent variables. So it is, when I give you demonstration I will give you more into detail and the application. So when you go for the partial correlation, when you multiple correlation, they use such a case of the psychology, sociology, economics, and where the researcher need to account the influence of multiple variables. So you have multiple variable to choose the facilities. Suppose who are working in the sociology and the even the psychology, there is lots of factor to you need to understand, and then only you can isolate the relationship of interest. Suppose I give you one example. Many someone is working of the urban planning or urban policy like this, and the government provide the many scheme. But how it's create the psychological impact or the social impact or economic impact. So if you want to check all those things, you need to go for the multiple variable analysis and isolate that, so there is no psychological thing, so it is open for the all the people, or there is a no demographic the relationship because it provides the service to the all people. So likewise you can do all those things. And the effect size measure, so effect size measure, it is very important. That is the Cohen d it is actually when we go for the measure of the t-test or ANOVA, that time we just usually check the Cohen d value. Cohen d value is a 2.5, 0.5 and 0.8. Either commonly interpreted as the small, medium and the large effect. Large effect mean in which effect of the all the data set your value is a largely affected data set, or it is moderately affected or not. Then the eta square also measure for the effect size using the ANOVA. So it's determine the proportion of the total variance in dependent variables that is accounted by the independent variables. Its result is 0.01, 0.06 and 0.14 are the commonly interpreted as small, medium and large effect. Well, then you come to the power analysis and the sample size determination. Power effect, so power effect is the statistical power is a probability which is determine the given size that truly exists or not. The researcher often conducted the power analysis to determine the appropriate sample size. So, so you are working of the might be working in the Agartala city, so their population is the more than so 4 lakhs, 5 lakhs as per the 2021. I don't know the 2020 2011. I don't know the exact figure of 2021 census report. So, but it is not possible to take the 10% or 5%, because that is also very very large, because as a researcher, as an individual person, it is very difficult to conduct. So you need to analyze is the power effect size, then come out with the desired level, and then you will design your sample size. Then the type 1 type 2 error. In the power analysis, there is a balance of the risks of type 1 error. Type 1 is the false positives, it is actually called the type 1 error, and the false negative, it is called the type 2 error. Okay, by controlling the significant level, the alpha, and the desired power is the 1 minus beta. So those are the basic thing, and researcher can minimize the chance of the incorrect statistical decisions. So when you are going to the field, data driven solution, want to give some data driven solution, you should be very much careful. No one will taught you like this way. The power analysis, how to determine sample size and go. This is all are about the research methodology. So, but here I just give some basic. Otherwise, you cannot use properly your knowledge in SPSS, because they give you the result, but that result might be misinterpreted. Got it? And the sample size calculation, there is a various software, even the online calculator is there available to assist determine the your study, whether it is the adequate number or not, and the appropriate sample size or not. But desired power and effect size you need to understand first. Then for the non-parametric test, whatever we discuss about the thing that is for the parametric data set, but for the non-parametric data set, not meet the assumption of the parametric data set, mean the normality or the equal variation, that time you need to go man warning you test. It is compare the difference between two independent group, and the Wilcoxon signed rank test. It is compare the difference between two related or paired group. It is need to understand for the non-parametric data set. And the factorial analysis, just it is not required in all time, but you need to understand that what is the factorial ANOVA. It is the extension of one-way ANOVA. Allow the researcher to examine the effect of the multiple independent variables as a factor on the dependent variables simultaneously. Okay, and the main effect and the interactive effect. You need to understand the two effects. So in the general case, we are not going to the interactive effect. We just check the main effect only. But interactive effect, there is a two effect. The factorial ANOVA can identify both the main effect of the individual, factors, and the interactive factor between the factors, when within the group, provide the more comprehensive understanding between the relationship of the variables and the interpreting the result. That is the most important thing of any statistical software you can use later. If you are becoming expert, you can use in R also. That is if you able to write the code. Otherwise SPSS, Stata, as well as you can use the Statistica. All those softwares are very good. Even the Minitab also very good. So those thing, as well as the magnitude of the effect, and using the different size, like the partial eta square I discussed earlier. So from that you can understand whether you know just go back the partial eta squares measure the effect size. From effect size you can understand the factorial ANOVA is significantly distributed or not. And then the choosing the right test. So any test you can perform in your SPSS software, but thing is that whether those things are rightly right test or not. First of all, why you just ask yourself why you do this test, why not any other test. So that is very important. Why you go for the, suppose correlation? Why not chi-square test? Why not in the other state? Even in the, there is a lots of thing to analysis the hypothesis like the t-test, ANOVA. Why you not go to t-test or ANOVA like this? So you need to understand all this. And the common mistake is the failing to clear define research hypothesis. It is very important. And if your hypothesis, research hypothesis, is not very clear, so you will be, there is a chance to make mistakes. Ensure they aligned with your objective. So first of all, there is a correlation between your hypothesis and your objective. Suppose your objective is to find out the effect of COVID-19 on tourism industry. So your hypothesis will be, uh, well, is there any significant relationship between the COVID-19 and tourism, mean passenger, mean visitor mobility? So you need to analyze, mean the correlate the, or ensure that there will be the aligned with each other, and the violation of the statistical assumption without doing normality, assumption or homogeneity of the variation check. So just without appropriate in the, corrective appropriate measure, you just choose. You know that how to calculate mean, central tendency, other central tendency, or measure of dispersion. So commonly we use the mean and standard deviation. So we just perform that thing. And interpreting the p-value incorrectly, such as the equating the statistical significance with the practical or clinical, significance. So p-value is, sometimes you misinterpret the p-value if it is not properly defined. So you should be very much careful on that. And the interpretation of the result, so the researcher must careful to examine the p-value and the probability value, effect size, and the other relevant metrics determine the practical and the clinical significance of their findings. And proper interpretation underlying the limited statistical result, underlying the assumption. So drawing accurate conclusion from the data essential to making the informed decision. Informed decision mean that data driven decision. Advice in significant scientific knowledge, and misinterpretation result can lead the incorrect interference and mislead the conclusion, which can serious implication of the policy, practice, and future research. Got it? Thank you. And I will going to demonstrate, and before that I just would like to discuss with you that is it clear to you or not? Devajyoti, is it clear?
Yes, brother.
Sankar,
Yes, it is clear. All clear.
Bhumi, Navam? Okay, Tilottama also says okay. Fine. So just share my screen again and just demonstrate with some data so that it will be easier for you to understand. Well, fine. So then I will go into just just a minute. And so if I go to resources, First you need to add your data. Just go to the file, import data. So I use the Excel data. So click it here. So just go to the data infrastructure. Okay, so just click it here. Just put it okay. Well, my data set has been added over here. Okay, and then what I will do today, so that is the first of all you need to go here and you need to go here for so t-test. For t-test, suppose I give you just a minute, you just click over here, then one sample t-test. Okay, then click it here. So one sample t-test mean, if I consider the suppose number of the ticket counter, so if I choose the number, suppose in the drinking water collection point, if I consider, so there is any significant differences because it is one sample. I just take one sample. I need the test value. So significant differences between more than 5 or not. Suppose I consider the 5 as my predetermined value. Okay, it will determined by the researcher. Okay, and then you just check your confidence interval percentage, that is the 90%. So my significant level will be less than 0.05% if that result is significant. Okay, just put it okay. So you just check 0.03 is significant differences between the different railway station in terms of the drinking water collection taps. So some station is high, some station is very low. Okay, I put the value like the 5, so 5 is the considerable figure, more than 5 and less than 5. So there is a mean differences from the 5 value. So it is, that is the significant correlation, less than 0.043 actually. So, and if you go into another analysis, you just close it and then go to here again in your data set. Then you need to go again in the compared mint. There is a independent t-test, independent sample t-test, you know it very well. So in the group variable, so group variable mean if you have the male female data set or any other group, and here is a test variable. So test variable, what is the independent variable? I don't have that kind of data set, so that I cannot demonstrate all this thing. But though this is the method, you can choose your independent variables and the group variables. Again you need to go here and you must select this thing. Suppose you can put the 99% also, you can also put anything based on your sample size and the power effect analysis, you can go into that. And then you go to again here. So we discuss about the paired sample. So pair sample t-test also, there is a similar way. So pair 1 variable 1 and variable 2. So pair 1, suppose if you consider that suppose okay, fine, the pair 2 is the track, well fine, and then go to here again. So 95%, okay, continue and then put it okay. So standard error, there is a in correlation, yes it is significant. Statistically paired mean the number of the platform and track. So there should be a correlation. So correlation mean if you consider that platform, every platform should have track, so definitely it is positive correlation. So 0.78%. So mean not percent, 0.78, r value is 0.75, more than 0.75, so that it is significant. Your p value is far less than 0.05, so it is statistically significant. Okay, this is the pair sample, so you can uh, justify your hypothesis. Yes, there is a I mean, it is alternative hypothesis, your hypothesis, there is a no significant relationship between number of platform and number of track, but we found over here, so there is a significant relationship, so there is an alternative hypothesis. Okay, so then again you need to go to analysis, go to your here, so you learn here from t-test, independent t-test, pair sample t-test, and here one way ANOVA. Well, so one way ANOVA, in case of one way ANOVA, you need to know that your dependent variable and the factor. So suppose I choose the length of the platform. So length of the football pitch, length, total platform width, platform, so platform length. Okay, fine. Well, and the number of the water trap. So then you need to go into polynormal, or efficient value you can add over here, and then you need to check that the post hoc test. Okay, so I usually prefer the Tukis because I can explain Tuki. You can also do the Duncan analysis and the Gonfani analysis. So this is the thing, and you just, and for the non-parametric analysis you can go for the games Howell test. I just mentioned over there in my presentation, so you can go into this also. Just put it continue and okay, so you can see that is the value is 0.03, mean that is statistically significant, mean there is a relationship. If that is the longer railway station, that's mean there is a probability of the number of drinking water tap will be more. Okay, that is equal distribution within the certain distance. It is usually divided. Well, then you need, you can analyze this comparative mean and all, everything you learn from the comparative mean section. Okay, even mean and standard deviation, you can also collect the different independent variables. The similar way you can put the your range, mean it is descriptive statistic also you can do from here also. Okay, I will not go into it because you can do it from the your this part, this section, descriptive statistic and then descriptive, so you can do every descriptive statistic. For comparative mean you can do all those things for the hypothesis testing and all. Then you need to learn about correlation. In the correlation there is a, I just discussed about the bivariate and partial correlation. So in the bivariate correlation, mean there is a two variables. Suppose there is a, just again choose the this one, and the number of the drinking water tab or drinking collection point, so whatever it is you just collect over here. And the, because this is not a rank value, that's why I am going to the Pearson. But if it is a rank value 1 to 1 to 27 like this, there is a 27 railway station, if I the rank them, so you can use the Spearman correlation analysis also. Just go to the option that you can add the mean and standard deviation also here, and just continue, and you can see, you can go for the two test, total significant test. Okay, for the ANOVA and the flag significant correlation. If there is a significant correlation, there should be a star. That is better for your, that is easy to understand or easy to interpret. Okay, click it. Okay, so you can understand. So see, that is the significant correlation, that is a double star.
Did you read this? Why?
So this is clear. Is it clear to you? Sankar, Tilottama, Rumi, is it clear?
Yes, it is clear.
Yes, yes, yes.
So this is a very simple thing today. Whatever we discuss about that, you can easily do. But most important thing, how you interpret your data set. So that is the main thing. So the hypothesis you can easily test from this, and the correlation bivariate you can understand, and then partial correlation analysis. So suppose your ticket counter, it might depend on the length of the platform, might be depend on the other factor also. So there is no passenger data set actually. So controlling factor, I just choose one controlling factor. Okay, then go to option, you can add the mean and standard deviation, even you cannot also. So our main purpose is only check the display the actual correlation level, and we are just going to the total significant test. Okay, so even you can go quantal also, but you need other, suppose just you can add many in multiple thing you can add over here the controlling factor. Okay, so then you need to variables you can add more variables because it is the multiple. So you are partial, then you can go into it. Okay, so I choose the two thing, and the controlling factor, all are the controlling variables. See, and those are the relationships. So there is a two that is not statistically significant. That is also not statistically significant because based on the value you can easily understand whether it is statistically significant or not. This is not statistically significant. Okay, so you, because I have only this data set. If you have the real time data set, then you can understand and better. Then in the correlation section you can do another thing also. This is the new addition of the SPSS after version 23, that the canonical correlation, that is the group correlation. So suppose in the water analysis, water quality analysis, so suppose those are the some parameter are set 1, consider the not numeric value. Okay, fine. So fine, you can add, suppose those are the one group, and might be this is the another group. So just another group, and then you can analysis the, is there any group correlation or not. Here you can the root name, score value, and other thing also there. So not required much. Then you can go into it. But my data set, yes, canonical partial correlation, canonical correlation. Just a minute. What is that? Yeah. So you can see the group 1, group 2, group 3. So is there any significant relationship or not? Set 1, canonical correlation. Set 2, set 3. So an unstandardized, this case of the standardized canonical correlation, and this is the unstandardized. Mean they cannot calculate the mean and standard deviation. So just those are the loading factor. So loading factor is factor loading actually. First you need to go into the factor analysis, and then you can better analysis all those things. So set 1 by self, set 1 by set 2, set 1 by set 3. So likewise you can go into the group correlation also. Those people are working in the different factor and all, they can go into the canonical correlation. So from here they can analysis, and there is some model also, univariables model, because if you need to know your dependent variables, suppose this, the fixed factors, suppose one and multiple factor will be there, and the random factor might be, you can consider the random factor. So you can also do like this, and then the covariant, everything you need to know. Then you come under the model. So and the full functional model, there is a many factor also there, build theme and the interactive model and all. then you can put it okay, so they will put you the result, but my data is not rightly distributed, so that the result is not good, so that's why 0 0 0 0 0 0 like this. So if you have the real-time data set, you can do this thing well. So this is the basic thing for the module uh, 4 actually. In the analysis part we will go into the suppose non-parametric analysis, so we know that the legacy dialog, and so from here you can go into the chi-square test, one sample t-test, and also the randomization of the value, so you can go into this. Okay, so in the chi-square test, suppose your list of variables for the non-parametric, because it's first of all you need to go into the normality assumption, otherwise your result will wrong like this. Okay, you cannot explain, but software can give you the result well. So there is a because this is for the asymmetric dataset only, but even you can use the Monte Carlo, so sample size is more than 1 lakh, so that's what in that case you can use over there, and suppose this, and then put it okay. So my I know my why the result is 0 0 0 0 residuals value, because my data set is wrong. Okay, that's why. So when you use the original data set for your research purpose, so even in the last class in the module 8, you just demonstrate your performance, so whether I will just give you some tasks and data sets, so whether you were able to do or not, so we will check. And then in this case this much of the, this is for the hypothesis testing, and this is for the correlation. Those are the major factor. In the next class we will discuss about the regression model and different factor analysis, cluster analysis, forecasting, all. So there is a lots of thing actually. Main thing of your course associated with the analysis part. So in the descriptive statistic you can do, you can perform, you can check your hypothesis, you can do the correlation. So that is the basic thing for every research paper or your dissertation or thesis, you require all those things. Even in the factor analysis we will go for the factor analysis, corresponding analysis, optimum scaling, and all. For non-parametric analysis you just go into the legacy dialog, and from here you can get the chi-square test and the one sample k test, one sample independent test, and all. And related sample, sometime data is related, so you can check the related sample also. So for that you automatically compare the observed data set. Yes, you run. So you need to check your data set for the test data set, suppose these and these, suppose you can run this. So from here you can get the non-parametric data set sample. Yeah. So but this way you can get the result. I am also get the result, but I can't explain properly, because you know why. Suppose I discuss about this, no, the related sample for the well Cookson signed rank test. So I discussed, but you need to understand your data first, then only you can provide the best solution, provide the right measurement. Got it? Okay, so cancel, no, okay, close, no, I don't want to save it anymore. Well, so I just stop presenting, yeah. Well, so Devajyoti, is it clear to you?
Yes, Dada.
Sankar?
Yes, yes, clear. All clear.
Okay, Tilottama?
Yeah, it's clear.
Okay, so that I will send you some data set to you. You just run whatever you learn, and you will just practice on that particular data set, and we will set next Wednesday around 8 or 8:30. I will send the link. Before that, you just practice a little bit so that I can also understand whether you are properly trained or not. So where is the gap, so I can put more emphasis on that particular area, so you can learn better, right, Rumi? Hello, I'm audible? Well, so yeah, I will send the data and I will upload this recording after the class, because last recording I am unable to upload due to some reason. So I will just check and upload the two things. So you will just revise. If you have the own data set, you can practice with that, so that I can guide you more better, so that result you can also use in your research paper or your master dissertation or your PhD thesis. You can use over there, so I can guide you well. So see you in the next class. Bye, good night.
Good night.
Jyoti,
Okay, good night.
good night, good night.